Okay guys, today we're going to talk about inscribed angles. This is Tuesday's lesson, May 5th, I believe, Tuesday. We're going to go by the warm-up here, so that's basically just solving equations and get right to where we need to get to here with inscribed angles. An inscribed angle is going to be an angle that has its vertex right on the circle, and the two sides are chords. They go from one point in the circle to another. One point to another. So this is your basic definition of an inscribed angle. Okay. Now, to find the measure of an inscribed angle, okay, your angle here, angle D, okay, is going to equal 1/2 the measure of arc AB. Okay, so whatever this arc is here, this angle is going to be half of that. Now, some things I like to do when I see something like this is to basically say, if this angle is 1/2 of this arc, that also means you could write this as 2 times angle D is going to equal the measure of arc AB. And that gets you right to where you need to go to. It'll instantly set up the equation. I kind of like that a little bit better. So 2 times angle D is going to equal arc AB. Okay, and we're talking about inscribed angle. Remember, when we did a central angle, whatever the measure of the central angle was, the arc was the same measure. Okay, here it's a little bit different with an inscribed angle. It's important that you know the difference between those two. Okay. Look at our examples here. Okay. And they're going to give you one measurement or the other. They're either going to give you the arc or they're going to give you the angle. Okay. And they have this in bold. Okay. This arc is what they want you to find the measure of. Well, we know that 2 times, since this is an inscribed angle, the measure of R, 2 times angle R, is going to equal the measure of arc STQ. Okay? So 2 times this is going to equal what your arc is. All right? So we know, like I said, you're always given one of the measurements. They give you the measure of the arc. You know, if you have this box, this arc is going to be 90 degrees. It's a right angle. Okay? So now R here is going to be 2. So that times R, 2 times 90 equals the measure of arc STQ. Okay, so 180 degrees is going to be your measurement of arc STQ. Okay. Go with the darker marker here. Okay. And again, they do the same thing here. They give you the measure of the angle here. So we know that 2 times angle Y is going to equal the measure of arc ZWX. Okay? And we know Y equals 115 degrees. So 2 times 115 equals the measure of angle ZWX. 230 equals the measure of arc ZWX. 230 degrees equals the measurement of arc ZWX. Okay? Now we get down to the bottom here, instead of giving you the arc, the angle, they give you the arc. So 2 times the measurement of angle M is going to equal 100 degrees. Okay? So we know that 2 times angle M equals the measurement of arc NP. Okay, and we know that 2 times angle N, we'll make this angle M a variable, call this X, equals, we know the measurement of arc MP is 100. It's 100. Divide by 2, divide by 2. So X, or our angle N, one and the same, it's going to be 50 degrees. Okay? Because 2 times this angle equals this arc. Okay? So it's important that you set everything up properly. Now, I'm going to show you some problems that have multiple chords in them. And it might get a little bit confusing, but I think the key is when we look at these problems that we're going to look at is that you kind of look at things one chord at a time, okay, or one angle at a time that you're seeing. Okay, they want to know the measurement of each one of these angles here. Okay, so they're talking about, first off, measurement of angle AEB. Measurement of angle AEB. Intersects this arc right here. Okay, so 2 times angle AEB. You have multiple angles, so you have to list it with 3 letters. Angle AEB is going to equal 60 degrees, because this is 1/2 of what this arc is. So 2 times, we can divide this by 2, divide by 2, so angle AEB is going to equal 30 degrees. Okay? Or you can just look at this. You see this angle right here, this inscribed angle, you know, it intercepts this arc. 2 times this angle equals this arc, or 1/2 of this arc equals this angle. I think it's important to understand one and the other, you know, and to understand both of them together. Okay, so this would be 30 degrees. Okay. Next thing they want you to look at is angle, I went to the end one here, angle ADB, kind of work in reverse, but that's okay. Angle ADB. Angle A, and I'll erase this highlight here, where we know this is going to be 30 degrees. Angle ADB, angle ADB, okay? Again, it intercepts the same arc. So this angle is also going to be 30 degrees. It's intercepting an arc that's 60 degrees. Okay? So again, the key thing I think here is looking at each one individually. Okay? Then we look at our third one, angle ACB. Okay? That's right here. It intercepts this arc here, the same arc, that's 60 degrees. So all 3 angles intercept the same arc. So all 3 angles, inscribed angles, are all going to be 30 degrees because they intercept the arc that's 60 degrees, and the inscribed angle is 1/2 of that, or 2 times your angle, 2 times 30 degrees equals 60 degrees. Again, I know I say it over and over again, but it's important to understand the relationship between those 2. Okay. Let's look at a couple of examples here. Or no, we're going to go to our theorem. And theorem basically says we just kind of proved here. Okay, if you have 2 inscribed angles of a circle and intercept the same arc, then the arcs are congruent. It's really probably should be 2 or more. You see, we have 3 angles here that intercepted the same arc. Okay, if you have 4 angles, anything more than 2, they all intercept the same arc. They're all going to be congruent. Okay, and they're going to be half the measure of the arc. Because that's basically, the inverse of saying 2 times an angle equals an arc, or half of the arc equals the inscribed angle. Okay. I'm going to go, I think the rest of this we can cover at a later date. Okay, I think we're just going to focus on the inscribed angles again, and the central angles that we saw previous to this. Central angles are just the same as what the arc is, and the arc and the central angle are going to be one and the same. Okay, for an inscribed angle, half of the arc is going to equal what the angle is, or 2 times the angle equals the arc for an inscribed angle. Okay, so that's it. Again, if you have any questions, just email me, and I'll be able to answer you, and then we'll go from there.